like to have your attention, please. Good afternoon. My name is Kumar Tewan, and welcome to the Agriculture, IoT, and Big Data e-workshop series. For your information, I'll be the moderator for this session titled Introduction on Application of IR 4.0 in Agriculture. For your information, today's webinar series will be conducted in collaboration between Faculty of Agro-Based Industry, University of Malaysia, Kelantan, and also World Resource Webinar, which is led by Dr. Krishnan Umachandran. So distinguished guests and students, today we have the leading experts from different countries in the world, and they would like to share the knowledge on the IoT agriculture with us. Our honorable speakers for this session are Dr. Krishnan Umachandran, which is an expert in the Internet of Things. So as we are aware of, Internet of Things in the process of transforming the future of agriculture, and Dr. Umachandran will be sharing his knowledge and experience on IoTs with us. Welcoming without further ado, I would like to welcome our distinguished speaker, Dr. Umar. The floor is yours, Dr. Umar, please.
Okay, thank you. Let me share my screen and we go further. Okay. Dr. Kumara, can you see my screen?
Yes, please proceed.
Yeah. Okay. Good afternoon, friends, joining from UMK, Malaysia. It's 2 o'clock for you, so I have to say you good afternoon and good morning to Professor Barbara from Poland. Friends, this topic called Industry 4.0 is quite new to people who are in the field of technology. But, this is 10 years old for now. The reason why I'm telling you about the chronology of this Industry 4.0 in the beginning itself is, if we miss to learn what is Industry 4.0 now, then we would be behind the bus, later chasing it, what to know about Industry 4.0. And agriculture is not new to Industry 4.0. So my kind of positioning for today would be linking Industry 4.0 to agriculture so that you can put your knowledge, your skills into it, so that you can apply and get innovative ideas by using Industry 4.0 technologies in agriculture. Coming on to, what is Industry 4.0, because that basic introduction I need to give, though you all may know. See, this is a technology which is the 4th industrial revolution. Industrial revolutions had happened across the world since 1700s. In 1700s, we had the steam engine being invented, and from then a lot of mechanizations happened, and then new things started coming, not only depending on the effort and skills of the human being, but now onto the machines. That was the first breakthrough which the Industry 1 got. Then the second industrial revolution happened when the electricity was generated, and then the steel was also evolved out of the cast iron, which was in the first generation. So a strong metal along with the application of electricity gave the revolution that happened in the second industry 2.0. Then somewhere in 1945, when computer was invented, or semiconductors were into place, a lot of things happened by using mechanical and electrical forces. Then the smaller or miniaturization of applications with precisioning of our applications started. That is called Industry 3.0. Then in 1983, when internet was invented by Tim Berners-Lee, there he created a kind of a hypertext which can share from one computer to another without any connection. Then came the internet. So anything which happened after internet being evolved, that industrial revolution is called the Industry 4.0, which came first in the country called Germany. Germany was the one which started Industry 4.0, and then it started to take it across the world. See, what I'm going to offer you today is what is agricultural sensors, how is it being connected, and what is 4.0 technologies. So let us be clear with what is the takeaway from this kind of a training. When you have a clear objective of learning, then it is easy for us to understand this is what is expected, and then we can focus our thinking towards it. See, let us talk about a technology. Every year, if you see, with an analogy of a car, I can show you in KL or even in your Geely, you could see a lot of cars being used. Each one of them are a special, of a requirement to the owner. Why people choose different cars? Because they like something in it. They go on evolving from one car to another whenever a new variant comes and a new technology is being implemented into a car. But technology is not as we say about a car. A car may have only 4 wheels and a body and a seating capacity and its luxury of cozy and comfort which can be got when we are driving. But there is a special change with every variant of a car. That is the one which makes this technology be applicable, and people are willing to buy that car every year. When every model changes, people keep on have a crazy of buying new cars. So this craziness is being inducted through input called functionality, which is nothing but systems in a car. A car can have different systems. It can have an engine, it can have a transmission, it can have a gear, your fuel systems, it can have your braking systems, it can have your clutch systems, your cooling systems, all your comfort systems, whatever it is. These functionalities are the one which make the drive for a new car being sold into the market. So this car is also of a different type. Every time you cannot have the same kind of a car. See, for example, you take a engine, one system in a car. That engine can be of different type. It can be an online engine, it can be a V engine, it can be a rotary engine. There are a lot of types of engines. But then when you drill down and you go into it and see, the components are also different. Likewise, Industry 4.0 technology has different functionalities, different features, and different components. That is what we are going to see. As we proceed down, I wish to take you through the evolution of human demands. See, when we had the earlier Stone Age, the mortar and pestle with which our great grannies used to pounder on the dough, the grains and make it into a dough so that we can make a roti or a bread out of it. So they had only the stones. The stones were the machines one day. And as we evolved to the metal age, the stones were ground and it looked nice and it was very compatible for use. The second grinder, if you can see, it's of the same stone, but used by metal tools. Then came the mechanical evolutions. That is the Industry 1.0, where you have full of mechanical links and leverages which were. Then you see the next one, which is your electrical one. You have something more with a motorized kind of a support. And then you see another one, which is with the semiconductors, your PCBs, and it got the miniaturization of a grinder. And today, if you see, we have a lot of artificial intelligence oriented equipments which can mix, knead, flatten, cook, puff, everything of a bread and give you as per your software which you have done. And that can also get updated on a remote. So that is the kind of a day on which we are now today. So we have changed from what our great grannies had been helping us and now what we want to help ourselves with. Then came the cycle, the mode of transportation. See, earlier cycles were with a pedal and a saddle, and now you had a frame and you had a catch on the handlebar and you keep riding with your balance. It was on your balance. Then, instead of your effort being used, the motorized support came. Then there was a comfort and the speed with which came the bikes, razor bikes. Then later on came auto parking cycles. They can go and get positioned when you don't want them. You just alight and you leave. It will go and cling on to some kind of a wall which for its support. Now we have cycles which are autonomous, self-driving bicycles. where you need not do all your efforts you had done in your first cycle. It can balance even on a slimmest surface. You just need to sit and go. That's it. It has the high precision sensors, images recognition cameras, and the technology of artificial intelligence. So cycle has changed. Our way of cooking has changed. Many things have changed. So agriculture will also change. See, this industry 4.0, if you take it, I've told in the beginning itself, the technology is the prime, and to support it, we have functionalities, and to support it, we have features, and to support it, we have components. So on a base requirement, you have technologies which are simulation, systems integration, cloud computing, cybersecurity, additive manufacturing, augmented reality, IoT, big data, and robotics. I will touch upon it as we go further. These technologies are unique. These technologies have something in common, which is called the functionality, which is the interoperability, transparency, real-time data acquisition and processing, and digital automation. Interoperability means you have a system and you have a programming setup. When you do something in a programming setup, that changes in your physical system. That is called interoperable. And similarly, when you do anything here, it also changes. So this intelligent machine has a connection with do and think, like our brain and our body. Whatever we think, our body should accommodate. When it accommodates, it's healthy. Okay, so to make this technology healthy, you need to have that connectivity. Then the transparency, the machine, what it's thinking, and in a function, what it is delivering, if it is to be same, then the both reading and understanding of the machine and the input device should be same. That's where the transparency comes. And also within the people. So what you do here across the world, anywhere in the place, it should be the same. That's called transparency. And then real-time data acquisition. What you do today should be the one which the machine should take. That juncture, what you do, that's called the real-time data. And the digital automation, everything is done through the computer or a cyber system. This is where you give data in the form of 0, 1, 1, and then the machine takes up and it automates and it functions. This is the functionality on which the above technologies are having a footover. Then comes the features. See, this interoperability, transparency and all has to have some kind of a base. What is it? That's called the cyber physical system, artificial intelligence, machine learning, predictive data modeling, and digital twin. This I will cover as I go further. Coming on to the components, the hardware, software, peripherals, everything. See, there is a myth across people that when Industry 4.0, it is going to kill people out of their jobs. No, it is going to have the same. But what happens is it is going to have a disruptive positioning of people and their skills. See, when you had your mobile phone was a disruptive innovation of Industry 4.0. A mobile phone can have a camera, it has a calculator, it has an organizer, it has a scanner, it has many things. It means it hasn't eaten the other inventions. But it is wholesome, available with you. But still, digital cameras are there. You still have the scanner setups there. You still have the calculators being sold. You still have the watches being sold. Everything will be there. But one set where people want to have a wherewithal will go on for this kind of things. So it's a sophistication which the Industry 4.0 tries to give you when we go on implementing it across all verticals, be it in manufacturing or wherever it is, or in agriculture, everywhere it is going to give a sophistication of your activity. See, industry, if you take, industry is not limited to one thing, and this Industry 4.0 is going to cover all these areas. Industry 4.0 is going to cover all your products. It is going to cover your services. Services includes all your banking, healthcare, education, electricity, aviation, waterways, sewerage, sanitation, telecom, roads, whatever it is. All these places are going to be flooded with this Industry 4.0 technologies. And in products, be it a live product or a non-live product, everywhere it is going to have. In life, it can be food or a pharma, where plant, animals, human beings, everyone can be there, and being subjected to chemicals, fertilizers, pesticides, and insecticides, or whatever it is, which can be helpful or harm. everything is going to be covered by Industry 4.0. And then on the non-life products, which gives the cozy and comfortness to us, it can be on the FMCG or the utilities. These things can be onto all gadgets and all utilities. So as we go further, you can understand how Industry 4.0 has been crept, or it is being creeping into its positioning itself for our lives. See, when I said about internet, everything is going to be on internet, and every one of us is now using our mobiles for sending emails, chatting. We share a lot of photos. We have a lot of videos being shared. We learn a lot of things using our mobile phones, and many things are happening all through internet. It means internet is the one which does the conduiting of our content to a particular place, and then it shares with the intended person it has to reach. So this is where we have cloud computing. Cloud computing is the base on the one which sits into a internet. See, when you have cloud computing and you want to have Industry 4.0, then we are having our own confidentiality. What I send should not be seen by others. Similarly, what you send need not be seen by me or by anyone. So that's where we get in the security part, the cyber security. Once you have cyber security or a kind of a confidentiality being into place, then you should know what to protect. That is where the data comes, which is called the big data. And this big data is a growing data. It evolves, keep on taking new data. So from where it is getting? It's getting from the IoTs. These IoTs are nothing but sensors which are connected to physical machines. In Industry 4.0, we have two kinds of technologies which are onto physicality. One is the additive manufacturing, and second is the robotics. These two keep on spiking data to IoTs, and from IoTs you get into big data, and then the total thing gets integrated, which is called the systems integration. This systems integration can be simulated. We can be seeing it on a virtual form. We can do a lot of scenarios. We can do a lot of cases. We can say ifs and buts of each of these parameters, and then see. This is called simulation. What you do on a drawing board and decide which I will take up for a reality. That's called simulation. And then as you do it, you can also check it for various data and information, which is called augmented reality. So all these forms, which is either physical or your computing, is all together in an internet. This is what is the basic ingredients on which Industry 4.0 is seated upon. So now, let me give you an example so that you can understand, and then watch out how real data is being made into its for acceptance. See, I'm in India, I'm in Chennai. If I have to come to Geely, your UMK Geely, then what should I do? I can't run or ride a bike. No, I need to take a flight from Chennai. I come to KL, and from KL I come to Kotabaru. In Kotabaru, when I alight my flight, then I walk down to a cab, pick up a cab. So when I pick up a cab, I ask that person, I need to go to UMK Geely. So he checks through the Google map, and he says, okay, sir, this is the time it will take, and there are 2-3 routes. Which route you want to take? Then I also decide, there are 2-3, and whichever is minimal or less time consuming, I take and I go with them. As I come down, what happens is I'm not getting onto the Google map because the buffering cannot be taken by Zoom. Zoom will take a long time to show the buffer. So I've collaged the photographs to you. The aerial view of UMK, what you see, is the one which you can, as I go through traveling, I can see, and oh, this is the place where I'm going to come down. And when I land into one place where the vehicle says beep beep and the Google map stops, then I see the photo what I have in my hand and the reality is on place. I check, okay, there is a UMK logo. Yeah, there is a gate, and the same photo what I'm seeing is on reality. It gives me confirmation. I pay the cab driver, and then I alight, I get down. Then I see my left side, right? Okay, again, okay, there are 2 gates. Okay, this should be a big university, right? It gives me confidence. And then I move around, I see KFCs around. Okay, there's something to eat. There's a lot of happenings around. So it's a good point. And then I turn around and I see a hill, and okay, it's a nice place where, you have a nice location where the university is. It can give me the authenticity for learning. And then I turn around, still I see a camping site in front of me, and then, it gives me a better pleasure. And then when I turn around 360 degree, I see I have come to a right place. All this is possible through Google Earth. Google Earth functions with a lot of images. It is giving these data through a sensor system, which is called Custom Optics and Sensor System, through a Earth Viewer 3D. This is the geospatial data visualization application, which Google Earth has been using since 2000. See, what we are seeing in 2022, that has been started somewhere in 2000. See, these are the images which are being obtained with varying resolutions at different angles, from perpendicularity, from an angle, or in a front view, whatever it is. And then these satellites, aerial photography, and this GIS information system are all three-dimensional across the globe, which stream high-quality 3D imagery, which is the one which creates a giant multi-terabyte high-resolution image of the entire Earth. Now you can sit and watch what happens in any terrain across the world, and you can be sure about what happens, where you are going. That kind of a confidentiality, the sensor-built intelligence has given us. And today, there are around 4 satellites of Google, which is revolving around the Earth and giving around 6 billion square kilometer of imagery, which is outsourced from a different company, and Google is using it. Today, this function is being used for money making. All our aggregators, Ola, Uber, Grab, whatever it is, or our food deliveries, any chains of online deliveries you take from food, vegetables, or meat and fisheries, or tourism, whatever it is, whichever happens through this is making money out of this invention. This invention is the one which is the prime for our augmented reality, which is one of the technologies in Industry 4.0. As I go further, you can still more make a clarification and you can understand it better. See, sensors for agriculture. Now coming on to agriculture. Even before Industry 4.0 came into evolution, agriculture had sensors. It had a lot of mechanical sensors to identify the soil compaction and resistance. It had optical, it had dielectric soil moisture, it has electrochemical allocation, airflow, etc. To understand agricultural sensors in a normal way, or in a quick term or an analogy, you can understand the word called modeler. Modeler means mechanical, optical, dielectric, electrochemical, location, and airflow. These are the prime sensors which are used in agriculture. So for you people, you should know this modeler. How to use it is where goes on with your knowledge and expertise. Okay, as I go through, let me not read it out so that you are also already an expert, so you know what it is. Coming on to Industry 4.0. See, the Industry 4.0 machine. There are a lot of machines we use. In agriculture, you also use a lot of machines. If a particular machine is being connected with a sensor, see, sensor is the one which gives you a physical deflection or information. But this physical deflection or information should be transferred into an electrical communication. That's called the transducer, the second component that needs to be connected with a sensor. So sensor gives you the physical, transducer converts into an electrical impulse, and then the electrical impulse should be converted into a binary form, 0-1 form, so that the computer can understand. So these three, sensor, transducer, and binary converter together is the one which is called IoT. If you want to have an IoT built, if you want to start anything in your farm equipments, you need to know what is that sensor which you have to pick, what is the transducing thing which can help it, and then how you are going to convert it into a binary so that you can fit it onto your computer. So the other part is easy, because once you get the signal, and if your machine can learn that, read that signal, then the machine will respond to it. Then it can interconnect, you can interconnect the machines, and then it will have a feedback system, like it can accommodate and live together. That's where the typical 4.0 machine comes out with. See, sensors, I said modular sensors we have, but in addition to that, there are a lot of sensors like pressure sensors, displacement sensors, temperature, proximity, optical, many things are there. Similarly, for the transducing, you have a lot like oscillator, flow, inductive, photovoltaic, photoelectric, chemical, diaphragm, linear variable differential. All these things are there. But you can have these for a machine. Somewhere down the line, there is a link between a machine to a process through a human being. This is where we need to also capture the unique identification in people who are going to use these kind of a thing. Because tomorrow, if anything happens, we cannot go and blame each other, but we have to identify and see the things are set right properly. So that's where the security comes. Security is more important because people are the one who will make mistakes. Machines will not make mistakes because machines go with your program. So you need to identify who is doing it, or what kind of a username or password you can give, what kind of a phone authentication or email confirmation you can get, or patterns you can use, numerical codes, fingerprints, iris detection, facial recognition, olfactory receptor. That is nothing but your SPECT analysis. Each body has a different kind of a SPECT. So, can be identified through the, if you are lesser number of population, you can go for olfactory and more confidential. Then the tongue print, each tongue has a different kind of a print. All these identifications are available, and all these things can go into the Industry 4.0 machine, where it can give you an authentic kind of a work. It all depends on what kind of authentication you take, and then you can use it. Coming on to the requirements or the impacts, why any of these things in agriculture has an impact. See, agriculture also has manufacturing. You have a lot of things being manufactured in agricultural requirement sectors. You have engineering in agriculture, you have material use in agriculture, you have asset performance, you have supply chain, you have life cycle, many things. But these are all impacting what? Because the autonomous exchange of information is going to be there, then all these things are going to be threadbare open. So there's nothing going to be hidden in any parts. Then there are trigger actions. One action gets completed, another action takes up. Then means there's nothing confidentiality. You can put any people or any place or any kind of a function that can handle. So you scale down or you break down the usage to the machine requirements. Then on the controls, drives, costs, quality, and consistency, based on all these things, new inventions, innovations happen all across Industry 4.0 to any fields or verticals of its requirement. On the products and services. See, as we keep thinking and proceeding further, but there are certain pullers, why we have to do and what. See, already there's a lot of impact on climate change. There's pollution, which is depleting and affecting our lives. Energy demands have grown up and it is depleting, not only due to war or other things, but the energy itself is going down because we are using the same energy. We are not using alternative energies everywhere. Then the urbanization pressures, everyone wants to have a different kind of life than what they are living. So people move towards urban collations, they move to cities. And then we have also aging and elderliness. They have to be protected till their end. See, these things are all depending on the productivity. These things affect our productivity. These things affect our growth. These things affect our customer satisfaction, because everywhere you cannot have the same kind of parameters that can help you out. So you need to have a varying parameters of your products and services based on the lot of derails what you have, so that your human commands and auto corrections can be made in a proper way. See, once you know the big picture, then you can do an Industry 4.0. Industry 4.0 is not for a small scale innovation. It takes a bigger picture. So every small act of yours is going to have a bigger impact. So you should know better and you should understand, then you have to get into Industry 4.0. See, taking all these considerations, UNIDO, United Nations Industrial Development Organization, they have come up with an agenda called Agenda 2030. In their 9th goal, they have specified to build a resilient infrastructure, promote inclusiveness, sustain industrializations, and foster innovation. This is what they are trying. So what do they mean by resilient? Resilient means you have a lot of problems, either be man-made or God sent. You have infrastructure which requires people to be in a life so that they can get on to the next day to go work, or they can have their livelihood. So it should be resilient. If anything happens, then the infrastructure should be quickly made. So the first part is infrastructure. Then promote inclusiveness. People can easily divide themselves, but to get them all together, then only you have a lot of things can be progressive. Otherwise, they will fight, they will be only competitive and it will yield nothing. So promotion of people to be together is the second point of UNIDO. And sustainable industrialization. See, in a sense, I do something and after a few years, I change it. No, you can change, but the base of it should not change. The essence of its delivery should not change. So your industrialization should be in a position to give a sustainability of its flow. This is where the industrialization or the capital investments for a mass production has to be thought over. Then foster innovation. See, everything what we have today was a dream of yesterday. What we dreamt, what our grandfathers or grannies thought about are today, in reality. And what we are thinking today will become a reality of the future. So innovation is the one which is continuous. So based on this, UNIDO on its 9th goal, they said to get this, they said infrastructure means superstructures, all buildings, connectivities, dams, bridges, railway stations, your place of work, your markets, everything, all should be connected with roads, waterways and whatever it is. And all these facilities should be the one which needs to be protected, and it should be smart enough to be reconstructed in case of any kind of a problem. So you should be in a position, we are going to live, as long as we live, it should be alive. So you create a structure, and so you go on with that innovation. And then the inclusiveness, dividing is easy, I said earlier itself. It's like caste, color, creed, gender, refugee status, and then the race and all the stuff. See, all these are small kind of, satisfactions for human beings. If you cannot keep on dividing people, because brain is the one which is common and is available everywhere. So you need to have this kind of inclusiveness built into the system. Then on to the industrialization. Bioscience, medicine, healthcare, energy, defense, transportation, and IT enablement. These were the things, Industry 4.0 were foreseen by UNIDO as the prime industries that would thrive for the next few years, or the one which has more pronunciation to be lived later. Then the innovation, novelty releases and all these upgrades, because we want to have more money. If you want to have more money, you need to give new products. And when the new products come, then there'll be more people to buy it. And then there's a flow of economy. To have all these, you need to do first education of the people. That is the knowledge enrichment is required. Then the skills, application of knowledge, and the competence, successful application of knowledge, all these things have to be done. So they created a kind of a group in Australia called CDIO. It's called Conceive, Design, Implement, and Operate. This is a group, which is again a voluntary group created, thinking about Industry 4.0's group. And they are the ones who, tell the competence skills that is required. And as we go through, Industry 4.0 balances between the functionalities and the features. The functionalities, I said in the earlier part, the interoperability, digital transparency, real-time and automation. And that is based on the data modeling and things, which I said I will come to it later. So I'm going to touch that now. See, before I get into it, any machine, any device, any gadget, any equipment, take anything which is of a physical stage, which has been designed up to the Industry 3.0 revolution, is now going to get into an internet mode that is called the cyber state. When the physical machine gets connected with an internet, that means it needs to have signals. That is where you get the IoT in place, where IoT is nothing but a sensor environment. You have a lot of sensors in the environment, and that keeps on signaling through the internet, and then the machine gets held up to its use. But keeping on getting a sensor and information using is not right. So you need to have intelligence. That's where the artificial intelligence comes. So this artificial intelligence is going to be connected with two learnings. See, when are we intelligent? When we learn something and we do the right thing. That is called intelligence. Okay, here in Industry 4.0, we have two learning systems. One is the machine learning and then the deep learning. For example, you are going outside and you're coming into your room, and it's a daytime and you're sweating slightly. So you want to have your aircon to be put on automatically. So you can do it when you have a motion sensor in place. When you move in, it will sense and the aircon get started. And the slightest innovation can be that aircon can be connected with the outside temperature. If the temperature outside can be recognized, then accordingly it can change the temperature for your suiting. This is called machine learning. Automatically the machine learns. But sorry, what is a DL?
Sorry, Dr. Umar, the times, can you conclude in a minute or two?
No, I would slightly take some time and I'll close it as quick as possible.
Oh, sure.
Okay, see this DL, and I may not go through the full presentation, but I'll finish as quick. See this DL, deep learning. See, if you're sick and you're coming into a room and the temperature, aircon gets started, but the aircon will have a sensor to see who is the user. That is called the user dependent. If you are ill, accordingly, your temperature in your aircon will get slightly modified. According to your use, this is called user defined. User defined is your machine learning. User dependent is called your deep learning. Okay, with this, I know I can stop. But before I stop, I will show you the one slide which is required. This is the technology which I said. In the beginning itself, there are 9 technologies. To remember these technologies, you have to take this acronym 2S, 2C, 2A, IBR. I repeat, 2S, 2C, 2A, IBR. If you can remember this acronym and that modella, then this is sufficient enough to understand what is Industry 4.0. 2S, simulation, systems integration. 2C, cloud computing, cyber security. 2A is additive manufacturing, augmented reality, IoT, big data, and robotics. These are the technologies of Industry 4.0. Okay, so remember 2S, 2C, 2A, IBR, modella for your agricultural requirements, and then how these things have been synced. Okay, with this, I stop my presentation. Thank you, Dr. Kumar.
Thank you, Dr. Umar, for very informative and interesting talks. Ladies and gentlemen, now we have come to the question and answer sessions. If anyone have any question, please feel free to ask any questions. Anyone? If no questions, Dr. Umar, I have one question because this is commonly asked by the students and members from the industries. Do implementation of the IoTs in agriculture setting is cost effective?
Yes, it is very effective, provided you have the scale of application. See, if you have a small scale, you're having a small farm, and it is completely human dependent, then you don't require a machine. So it all depends. If you have a big area to be covered, more animals to be covered, you have a big market to be catered with, then using sensors of IoT orientation along with big data is required. Otherwise, it is not.
That's the main question that we normally will ask by the industries, especially we have quite a lot of numbers of smallholders in the rural areas.
Okay.
I think that's all. We have come to the end of part of our sessions. We'd like to say thanks again to our honorable speakers for the informative talks.
There is somebody who is raising their hand called Palani Chami.
Okay, so can you hear me?
Yeah, I can.
Actually, I come from outside. I'm not related to agriculture, but I am working on the IoT for my hobby project. My question is, what kind of sensor or what kind of monitoring you people are doing in the agriculture? Because what I'm thinking in agriculture in my native, that is paddy. Okay, this kind of agriculture or sugarcane. So how it's implemented? I want the what do you call actual usage purpose of this. Can you give me an example?
Yeah, see, it's a nice question, Panichami. See, right from water, air, soil, your plant chromosomes, your nanotechnologies that are, affecting your chemical requirements of your plants or animals. Everything is being controlled by Industry 4.0 or your IoTs. See, right, that's where I said about the machine learning and deep learning. Deep learning is the one which takes every consideration of your senses. See, there are labs which have used to grow cucumber. Cucumber length it has been taken. In Israel, they have checked about the plant beat. How the plant has to beat, that is being evolved via IoT. See, a lot of things are there. See, this is the first, introduction I'm giving. I may not be in a position to clarify you right away because this is a series. We have a series of around 10 lectures that needs to go. And as you go through, if you still are not convinced, then we will take your thing as a case and we will still continue to do it for you. No issues.
Okay, thank you. Just for the information.
Thank you, Mr. Balani. So any other questions from members? If no, then thank you, Dr. Umar, for your talk. And
now we have this test, Dr. Kumara. Can you share that link to them?
The link already shared in the chat. So please, Dr. Yuni, have you put the test? So
he has already put.
Yeah, please take the test, which is already in the chat box there. And then I think, can we have a photo group questions?
Maximum, Leonie has put 3 minutes. No problem. Anytime between 3 to 5 minutes. If they can finish, then I will close the Google Doc so that they can no further entries can get into it.
Okay. Asia, you are taking the photos? All right.
Hey, Doctor. Okay, sure.
David.
Okay, wait.
Please, can you turn on your videos, please? Done?
Okay.
All right. I think that's today. That is the end of session of today. So thank you again, Dr. Umar. So please, those participants, we have one more session with Prof. Barbara later, 3 o'clock. Please join the link later on. Right? Thank you very much.
Okay. Thank you.
Thank you.